So in the notes packet, number 6 on the front of the third page.
Notes packet.
Notes packet, not worksheet packet.
I was looking like, where is this?
G prime is defined on -2 to 6. The graph of G prime is shown on the right. Graph of G prime, graph of G prime. So I need to be careful when it's when it says find G. That's not this graph. This graph is G prime. It's just 2 line segments in a semicircle. G of 1 is 5. Find G of -2. Okay, it's going to be real tempting to say that G of -2 is 1.
But it's not.
But that's not true, because this isn't the graph of G, this is the graph of G prime. So I know something about G prime. I'm looking for G. What's the magic thing to do to get from G prime to G? I need to do an antiderivative. So I need to antiderivative G prime, and that will get me back to G. And then there's sort of 2 options with that. It's either a plus C problem or it's a bounds problem. And since I've got all sorts of numbers here, I'm pretty sure this is a bounds problem. So let's see. If I want -2, then I guess I should go from -2 to 1 of G prime, because that would be G of 1 minus G of -2. And I picked 1 because they gave me stuff about 1, and I picked -2 because that's what I'm looking for. How am I supposed to evaluate the antiderivative of G prime when I don't have an equation for G prime? Yeah, antiderivative and area go together. So this is an area problem. Okay, the area from -2 to 1. And conveniently enough, they made that, relatively easy for me. That's a triangle. 1/2 base times height. Oh, they didn't make it work out nicely, but 3/2 for that area. So 3/2 equals 5 minus G of -2. So G of -2, if I move things around, is 5 minus 3/2, which would be a safe stop, right? Looks like a weird answer, but you're in calculus now, so we don't care about weird numbers. I think that would be 3.5, but safe stop would be probably better. Find G of 5. I'm going to press pause. Why don't you try to find G of 5? Sort of encouraging. Almost everybody had this part right. It's like you knew how to set it up. You knew which x values to pick. You knew that the antiderivative of G prime is G. All good there. The big mistake was that one. G of 6 is going to be kind of the same thing, except you're going to have an extra area there at the end. So I think that'll just add 1 to your answer from B. I think, but that's skipping. Is that right? Okay, so 5 plus this area, and that area is -2 pi plus 1 equals G of 6, and don't mess with that, leave that alone. So yeah, I did add 1 because we added the area of the next spot. Number 6. Find the values of x at which g has a relative maximum.
You mean part D?
Yeah, part 6. Where'd that come from?
I think because we're on question 6.
Or because
And we
6
just did G
sort
of
of looks
6.
like a D. Maybe my brain is just whatever.
And we just did find G of 6.
Part D. Find the values of x at which g has a relative maximum. Justify your answer. Again, I justify my answer first because that tells me what to look for. So I even know how to start. G has a relative max when. So we should be able to answer that question or finish that statement. I keep meaning to make warm-ups where like you finish that statement without any other information. Like regardless of the problem, regardless of pictures or tables or equations, it doesn't matter. We should be able to finish this sentence. G has a relative max when?
It goes from positive to negative.
You can't say it though.
Oh, when the curve
When
G prime changes from positive.
G prime goes from positive to negative. You said it too. You said it. I think, Nick, you were going to get there,
Down
but
correctly.
when G prime changes positive to negative. And you could say goes positive to negative. That would be fine. The main thing they'd be looking for is G prime and positive to negative. So I want G prime to go from sloped up to sloped down. That would be a maximum. Yes. Okay. So, well, this is an easy problem now, right? Because what is my graph of? G prime. So when does my graph go from positive to negative? At x equals
1.
Wait, careful. 1, it goes from positive to negative. 5, it goes negative to positive. So at x equals 1. And it just says at what x values of x. So it didn't ask me what the max is. It just says where is it? Well, it happens at x equals 1, so I'm done with part D. Part E is almost the same thing. Relative minimum. G has a relative minimum when G prime changes negative to positive. G prime, I have the graph of G prime. So that happens at x equals 5. Find the values of G, the values of x, at which G has a point of inflection. Point of inflection, I'm already thinking second derivative then. Justify your answer. G has a POI when G double prime. Yeah, all you have to say is changes signs. We don't care if it's positive to negative or negative to positive. There's not two different words for that, which is a little bit weird because usually calculus has all this parallel stuff, but for a first derivative, if it changes positive to negative, that's a max.
Or a minimum.
If it changes negative to positive, it's a minimum.
But they just put point of inflection.
But point of inflection, there is no concavity
specific
one. You just, if it changes signs, it's a change in inflection. So G double prime. Okay, but I don't have anything about G double prime.
It's the slope of G prime, not the graph of G prime.
So yeah, I should probably say that. G double prime is the slope of G prime. And I have G prime, so the slope of the graph. And I could write that out, or what I have is fine. So where does the slope change signs? It changes a lot of places, but where does it change signs? At 3. It's going down, it's going down, it's going down. Something funny happens at 1, but it's still going down. And then it changes at 3. The slope changes. I said it, so shame on me. At x equals 3, the slope of G prime changes from negative to positive. Again, something weird's happening at 5, but the slope is positive to positive, so not worried there. So at x equals 3. Find the absolute maximum value of g. Okay, so not just the x value, but the actual value that goes with it.
And what if I don't want to?
Plus absolute is going to mean table with endpoints and critical points, but the endpoints is what people leave off. Absolute minimum, okay, well so it's the same process to find the absolute min or absolute max, so I don't mind them asking both, because that's no extra work. Okay, so x and g. My endpoints are -2 and 6. Did we already find those?
Yes.
Yes, we did, so that's nice. 3.5 was g of -2. G of 6 was, oh, I guess I should clean that up a little bit. 6 minus 2 pi. 6.28. So approximately -0.28 if I need that. That's not the right answer, but if I'm comparing things, I might need that to compare things. I've got the relative max and relative min. They already asked me for that.
Yeah, and you've also got the point of reflection.
X equals 1 and x equals 5. We have g of 5 already.
And we also have g of 1 because he gave it to us.
5 minus 2 pi. I don't want to think about what that is right now.
They gave us one in the beginning.
They gave us g of 1. Almost missed that. They just gave us that one. Okay, so I do need to. 5 minus 2 pi would be
-1.
right, 1 less than 6 minus 2 pi, so -1.28. So the absolute max value is, which one of those numbers is the maximum value of g? 5. And that happens at, it didn't ask for this, but just to be clear, it happens at x equals 1. So you would not have to say that, but if you're just kind of trying to convince yourself what's going on, and the absolute minimum value is,
5 minus 2 pi.
yeah, I better give the actual value, 5 minus 2 pi. If you put -1.28, would they, I don't know if you get,
Just don't.
yeah, and that happens at x equals 5. Again, that's not really part of the answer, but that helps it keep straight. Justify your answer. Justify your answer is
Draw an arrow.
the table. Yeah, you don't have to draw. I mean, they know what you're looking at. But the table is from the absolute. In fact, the fancy word, you don't have to even put this. What you did is a candidates test. But the candidates were the endpoints and the critical points. So if they saw the endpoints and the critical points, they know you did the candidates test. You don't have to give them your, the official name of what you did.
Don't forget about project.
All right, so today I would strongly urge you to do worksheet 4, the rest of worksheet 4, and even more strongly urge you that there is a project due on Monday. There is a project due Monday.
But it's only a half sum.
It's only a half sum of it,
it's
but
a half sum.
if you don't turn it in, it's a 0 for a half sum of it, so that's a big deal. There is a project packet.
I don't know if I was here when